Alrighty, let's see. So I've heard from a couple of people that they would like a bit of help understanding some of the SolidWorks problems that we've had in the assignment so far. I figure as an olive branch, due to all of the SolidWorks kerfuffles that we've been going through so far, I would record me going through each one of the SolidWorks problems. So here is the SolidWorks problem from homework 1, where we've got the ME, and we're going to begin with a new document. We're going to create a part file. At this point for yours, it should have already asked what units you want, but for me, since I'm on a personal install, it did not. So step one is always, always, always to set your units. We're going to go from MMGS to IPS. A good step two is to make sure that we have the correct drafting standard. So if at any point you have seen a note on your thing that says incorrect drafting standard, here's how you change it. Go up to our options gear, we go to document properties, and we want to pick ANSI from the overall drafting standard. I told them not to be deducting points for this, but to note it. However, at some point in the future, we may decide to start taking points off if we keep seeing it. But since it's been a trial and a half with the new VDI, we're going to mention it, but we won't take points. All right, so to begin with, we've got two different sort of features at different levels. We've got our M, which is sort of back a little bit, and then we have the E, which is set forward. So to me, that reads as we're going to need two separate extrudes. So one of them for the M, the other one for the E. Theoretically, you could do them in either order, but the M, in my opinion, is an easier place to start. So we're going to begin by creating a new sketch. So up to the Sketch tab on the ribbon, selecting Sketch. And in order to make sure that we match our orientation, we want the M to be facing the front view, or the M to be visible in the front view. So we're going to need to draw this sketch on the front plane. It is important that we match our orientations for full credit on the assignments. So let's see where to start. To me, this entire M has the same thickness to it. So we've got the same 0.4 offset across the entire shape. So I'm just going to start by creating the outside of our geometry, and then we can use the Offset Entities tool to pop it to the inside. So the exact location of the origin isn't that important for this. So I'm just going to start the origin, the bottom left-hand corner of our M. We can see that we get a line that goes up vertical. We can use the auto transition feature by bringing the cursor back to the endpoint, tracing out an arc. Then we want a tangent edge there. And there's going to be another line. Careful we don't snap to perpendicular because it is not perpendicular. But we got that other line coming out there. Reapply our auto transition tool just by bringing the cursor back to the endpoint and then tracing out an arc. Click again to place, and then we have a vertical line over on the other side. So step one, get the general outline of our shape. Check. Step two, let's apply any geometric relations that we might have missed. So one thing that we know is that both of these arcs are the same radius. So we've got the 2x R1. So in order to set them to be the same, we can hold down the Shift key on the keyboard, left click to select both of our arcs, and apply the equals. So that'll ensure that they remain the same. We also have this nice little guideline showing us that the point from the sort of the tangent point where it goes from arc to edge, those two are horizontally aligned. So we'll select the 2 points, apply a horizontal relation. Likewise, we can see that we've got these guidelines that go between the center marks for all 3 of our circles. So I'm just going to apply a quick horizontal relation to those 2 there. And the last 2 that we've got is the legs of the M appear the same length. So we're going to make the assumption that they are and select the 2 endpoints of our M, apply a horizontal. And the last one that we've got is we need one more tangent relation. So this one did not get added automatically because I was a little sloppy, but we can select that point, or we can select the arc and the edge, there we go, and apply a tangent relation there. Cool. So We've got our M is fully referenced or fully relationed up. Now we can start throwing some numbers at it. We can use our smart dimension. We know that the leg is 1 unit tall, so we'll apply a 1 there. There we go. We know these arcs have a radius of 1. Oop, good enough. We know the distance between the legs is 4 units, so we can measure from one line to the other. Plug in our 4. And then we know the middle of the M has that 80-degree angle. So to measure an angle between two straight lines, you click one, you click the other, and then click to place. We can plug in our 80. Cool. So this is the outside of the M. If we were skipping ahead and already knew thin features, then we would be able to use a thin feature instead of the offset. But since at this point in time we have not yet covered thin extrudes, we're going to use offset entities. And we know that the offset distance from the outside to the inside is 0.4. So we'll plug in 0.4 there. Then we can select one of these edges. As needed, you may need to check the reverse box. I have no idea how it picks what to start with as the default, but it's usually not too bad. And if we really want to be snazzy, we can check the cap ends and set it to lines. You don't need to do this. We can just draw those in manually because they're two horizontal lines, but I'm showing off, so we might as well. Check mark. And that then gives us a nice single loop. So some of you may have seen a note on your assignment saying multiple closed loops. So a single loop would pretty much be if we took our pencil, we set it at a point, traced all the way around our object. We would never come into contact with or cross any of our previous lines, and we would end right where we started when we completed the profile. So we do not want to include the E as part of this extrude. So we've got our first sketch down. Now we can go over to our features, select Extrude Boss Base. So the general rule of thumb is that the first extrude that you do, unless you have a good reason, you usually want to be mid-plane. So to prove that I'm at least not hypocritical on this perspective, we're going to set our direction 1 to mid-plane, but blind here is fine. This gives us a little bit more planes to work with, but once again, at this point in time when you were working on the assignment, we weren't really covering reference geometry just yet. So we'll get our midplane. We can see in our drawing it is 1 unit deep, so we've got our 1 inch, and check mark. Cool. So that gives us our letter M. Now we have the E. So we can see the E is sort of at this 0.2 unit offset inwards, but we can still see it in true size and shape from the front view. So we have a couple of different places we could start our sketch. We could do the sketch on the front plane again. However, I will warn this makes the starting and ending conditions for the extrude a little bit more complicated. So it works, but it's not something that we necessarily need to do. So instead, one that makes it a little bit easier, we can see that the 0.2 offset is defined based off of the back surface of the M. So if we create our new sketch on this back surface, so we can just left click on the face, and then there is a new sketch icon that comes in the pop-up menu. Then we can hit Control 8. Oops, that's showing us the back. Control 8 once more. There we go. And we're drawing our E over here. So this one's a bit more of a pain as far as the sketch goes. There's a couple of tricks we get to use, but they come in a bit later. So at this point, we'll just brute force it. So the base of the E is a circle, something like that. Then we have a smaller circle on the inside of it. I'm just going to set them up so that they're both sharing the same center point. Then we've got the little inward bit of our E. So that starts somewhere around there-ish, goes out, down, and over, but this one goes all the way to the inside. There we go. And then we have the base of the E. Oops. This can get a little finicky. So if at first it looks like it's trying to do something weird, just move the cursor around a bit and hopefully it'll pick up. I have no idea why I did that. All right, third time's the charm. hit escape to deselect the tool. We'll get our line tool again from point to edge. There we go. So this obviously has a bit too many lines to be our E. So what we're going to do now is use trim entities to get rid of some of the excess. So trim entities, I personally prefer power trim just because it's the default. You can click drag and it creates this gray line. Whatever the gray line touches, it cuts up until the next intersection. So in our E, we want to get rid of this. We also want to get rid of that and that. Ta-da! So one other thing that's important here, it's a bit of an optical illusion. We can see in the isometric that the E appears to be in front of the M. However, from our front view, we can see that the E appears to be behind the M. So the other trick that we have is the only way that we would be able to see the M clearly with the E in front of it is if that bit of the E isn't there. So we need something that sort of ensures that we don't have this bit of overlap in our E sketch. So there's a couple of ways. In my opinion, the easiest is if we use convert entities, and I need this edge and this edge, since they're the two edges that the E crosses over. We could get the entire profile, but that gives us a little bit more than we need, and we end up trimming away most of it, so it's not quite worth it. Check mark. So, following the same basic process we did before with the trim, we can use trim entities. I want to get rid of this bit of the M arc, because we don't need that, we only need the bit within the E. Likewise for this bit down here, and then for the E itself, we don't need that bit of it. So there we go. We then end up with just a nice sketch that only includes the portions of the E that are outside of the M. Time to throw some numbers at it. So smart dimension, we see that the outside of the E has a diameter of 2. So we'll plug in this, which defaults to a radius. So since we're not allowed to calculate dimensions, I'm just going to place it as is. And then we can go over to the liters tab on our dimensions, and we can select the diameter option, which doubles the value. This is SolidWorks doing the math, not us, so it's okay. So now we can plug in our 2. There we go. And you can edit a previously placed dimension by double-clicking on the number or single-clicking on the number. There's a few ways, but I always double-click because that's how it used to be when I started. Cool. We see that the distance from outer to inner is 0.4 units. So we can dimension from outer arc to inner arc, place 0.4. You can also see that this bit of the E has a 0.3 height. So dimensioning from the top edge to the bottom edge, place our dimension as 0.3. There we go. Then we also have this gap between these two horizontal lines is another 0.3. Yeah, this one's got a lot of dimensions in it. Let's see. We can see that the distance from the center of our E to the left or to the right leg of the M is 0.8. So dimensioning from edge to center, 0.8. And we can see that this bit of the E goes in 0.6. So from there to there is 0.6. Let's see, what are we missing? One trick that can be useful when working on SolidWorks problems is to have it open in a sketch program so you can cross off dimensions as you use them. I'm doing this off the cuff, so I forgot to do that. We'll do that for homework too. So let's see, we've got the 0.9 over here, which is dimensioning the distance from that horizontal line to the bottom of the arc. I'm going to do it the more complicated way just to sort of set a precedent, but you could just dimension from bottom of M to that. So dimensioning from that line to the arc, we see that it only allows us to dimension the distance from the line to the center point, which isn't what we asked for. So we're going to place this dimension, just hit our check mark, we'll modify the number later. And if we go over to liters, we can see that we can also change the arc condition, which defines what the distance is measuring between. So it defaults to center, but we can also choose min, which in this case does look like it gives us the dimension we want. So it goes from the line to the closest portion of the arc, or you could do max where it goes from the line to the furthest portion of the arc. So we'll use min there. Here, check mark. And this dimension is supposed to be 0.9. Cool. So I believe that uses all of our numbers, but we are still underdefined. So we need one more piece of information. And in order to figure out how we're underdefined, I find it useful to click drag on one of the blue points. So we'll grab just a random blue point, and we can see that the E can sort of still freely move up and down, which is not great. There are actually two ways that we can define this. One of them is from the leader of the 0.9. It seems to show that the bottom of the E is tangent with the extension of the horizontal line at the bottom of the M. So we could apply a tangent relation between that arc and this edge. Or we could use the fact that the guidelines between our center marks appear to be saying that everything remains horizontal. So we'll select one point and select the other point right there, and we can apply a horizontal relation that will also fully define our sketch. Cool. So we've got our sketch fully defined. Now we can go up to Features, Extrude Boss Base, Control 7, so we can click, then Control 7, so we can see what we're doing. And let's see. So we know that it starts 0.2 units in, and then it goes 1 unit. So to get it to go 1 unit, we're going to change this from midplane to blind. We want it going the opposite way, so we'll flip that. And then the starting condition, have it start at that offset, we're going to go to from and select offset. In which case then we can plug in our 0.2, flip as needed, and it looks from the preview like this ought to do what we want. So we'll hit our check mark, and that gives us geometry that matches up pretty well with what we've got. So last bit would be to set our material and check our mass. So if we right click on the material, we can apply copper. And to get our mass, we can go to the Evaluate tab, which allows you to ask questions about your model, and select Mass Properties, where we can see ours is given as 1.55 compared to 1.551. So if we wanted to be extra certain that we were on the right track, we can go up to our options over here and set this to Use Custom Settings. I'm going to bump up our decimal places to 3. So we'll hit OK. We can see our mass matches the mass that we were given. At this point, you save it following our naming conventions. So last name underscore first name underscore section underscore homework number or homework number underscore problem number. But so long as your name and your section is in it, we're pretty much good. And problem number will become relevant when you have multiple SolidWorks problems that you're submitting. But even then, we can usually figure it out. So anyway, that wraps for homework 1. I'm going to get recording on homework 2.